Unit 1 Chemistry, Chapter 7 Neutralization Reactions. So in Chapter 7, we've looked at properties of acids and bases and the pH scale. So now what we're going to look at is what happens when an acid and base are reacting and what kind of products are formed. So this type of reaction is called a neutralization reaction. And when you see the word neutralization, the word neutral should jump out at you. So in a neutralization reaction, what you are doing is reacting an acid and a base in the hopes of achieving a pH that is closer to 7. So what you want is a pH that is neutral. So the general formula is this: an acid and a base, which is these are your reactants, producing water and an ionic compound. So the water is what is going to make this reaction neutral, and ionic compounds are also neutral. What we also want to look at is what type of reaction is this. So acids are compounds, bases are compounds, water is a compound, and an ionic compound is also a compound. So this is another type of double displacement reaction. So we'll go over some examples of some neutralization reactions. So in this one, we've got hydrochloric acid plus sodium hydroxide producing water and sodium chloride. So what happens here is the hydrogen from the acid is going to bind to the hydroxide of the base to produce water. What you're left over with is a sodium and a chlorine, and that's what produces the ionic compound. Let's do another example. So we've got phosphoric acid plus potassium hydroxide. So again, the hydrogen from the acid, the hydroxide from the base is going to create the water, and then what you're left with is potassium and phosphate, and that's what forms your ionic compound. If the base is a base that has a carbonate ion on it, then you're going to have a slightly different outcome. So calcium carbonate. So this is your base, but it's a base that has carbonate on it, which we've talked about. Nitric acid. So that is my acid. So I know it's an acid because my leading element is hydrogen. So water is definitely going to be formed. The calcium and the nitrate are going to form my ionic compound, and then my brand new product is carbon dioxide, and the carbon dioxide comes from the carbonate that's in the base. So you're still making water, you're still making an ionic compound, but this time you're also making carbon dioxide because of the presence of this carbonate. So neutralization reactions have a lot of applications in everyday life. So I'll go over 3 examples with you. So the first one is neutralization by an antacid. So I mentioned antacids in the first lesson when I talked about common bases. So a neutralization by an antacid occurs when there's too much acid in the stomach. So the acid in your stomach that's used for digestion is called hydrochloric acid. Ordinarily, the pH of the stomach is approximately 2. So this pH is low so that it can assist in digestion. It also kills any bacteria that you might have ingested. If the acid levels get too high in the stomach, what it can do is it can cause irritation. And this irritation is something that is called acid indigestion or heartburn. So this is over here, we've got a picture of the stomach. So if the stomach acid gets into the esophagus, it can cause a burning sensation in the chest, often referred to as heartburn. So in order to counteract the acid in the stomach, people can take medications called antacids. So an antacid is a base. So an example would be like magnesium hydroxide or sodium bicarbonate can also be used. So if someone has too much acid in the stomach, what they'll do is they will take an antacid in order to counteract the high acidic levels. So an example here, we've got the hydrochloric acid in the stomach. So the formula is HCl, aqueous. plus magnesium hydroxide, also aqueous. And then what this does is it produces more water, and it's also going to take some of the acid and convert it into water and this magnesium chloride. So MgCl2 plus water. So what that does is it takes some of the acid that's in the stomach, it dilutes it by adding water, but it's also converting it into this magnesium chloride, which will make the person feel better. Another way that neutralization reactions can be used is in swimming pools. So we talked about this in our last lesson. So I mentioned that pool water has to be between 7.2 to 7.8. If it's too acidic, it can corrode the pool walls and any metal components of the pool. If it's too basic, it can cause the water to become cloudy and discolors the pool water. Also, when it's too acidic or too basic, it can also affect the swimmer's eyes. It makes it uncomfortable. So if the pH is too low, a base is added. So a common base could be calcium hydroxide. If pH is too high, then the owner could add an acid. So an acid that could be added is hydrochloric acid. Right, the third way that neutralization reactions can be used in everyday life is if there is a chemical spill. So if there is a chemical spill and you're spilling an acid or a base, you can neutralize it before cleanup occurs. So for example, if I was making some chemicals for a lab experiment, and let's say I spilled some acid, I wouldn't want to take paper towel and start to absorb the acid because acid is corrosive and it can burn my skin. So what I would do is I would add the opposite. So if I spill an acid, I would add a base so that I'm creating water, which makes it safer for cleanup. Similarly, if I spilled a base, I would add an acid to it so that I'm creating water so that it makes it easier for cleanup. There's an example in your textbook that talks about a sulfuric acid spill in a river. So sulfuric acid is an acid that's used to make batteries. So there was a cargo train that was carrying sulfuric acid to a battery factory. So the sulfuric acid unfortunately was in the cargo train and it tipped over, and the sulfuric acid spilled into a river called the Blanche River. So in the Blanche River, because of this excess acid, it was causing the plants to die, it was causing the water to become acidic, which affects the aquatic life. So in order to neutralize the acid, what was added was a chemical called calcium oxide. So calcium oxide in itself is not a base, but when it interacts with water, it creates the base called calcium hydroxide. The calcium hydroxide then reacts with the sulfuric acid from the spill to produce water and calcium sulfate. So those are the three ways that neutralization reactions can be used and applied in real life. Please try the homework questions that have been assigned from the textbook.